Good afternoon, everybody. Welcome to our next organic chem functional group lesson. Yesterday we introduced ourselves. We were introduced to Table R and the various pieces of it, looking at the different names and functional groups and patterns that we see for some of the easier functional groups. Today we're going to focus with a shorter lesson on two of the more difficult functional groups. We're going to look at ethers and esters. And now, when I say that they're more difficult, I just mean that the pattern itself, right, the pattern that you use to name them is a little more difficult to follow. Once you get the hang of it, just like all things in chem, once you get the hang of it, it gets a lot easier. So we're going to start by looking at ethers. We're going to pull up table R for ourselves here. An ether has a functional group of O not coming off of the chain, but actually breaking up the chain. So there's going to be carbons on the left of the O and carbons on the right of the O. And so the way that these are named, right, which we can see here, something like methyl, ethyl, ether, notice we have the YL suffix here twice for branches, right? This is a branch, a methyl branch. This is a branch, an ethyl branch, on the ether. So the pattern for naming these things, for an ether, you name the chain on either side of the oxygen, followed by the word ether. So when I see something like methyl ethyl ether, I'm going to have a methyl group, one carbon. I'm going to have an ethyl group, two carbons, connected by an O. Right, so methyl ethyl ether will have two carbon branches, right, branch and a branch, connected by an O. That's what makes it the ether. And we'll look at that in more depth in a second. For an ester, it is very similar. That's why I bunched these two together. For an ester, we have another thing that breaks the chain up, but instead of just being an O that breaks the chain up, it's a double bond O and an O to break up the chain. And so the thing that we do here when we name these things, the carbon chain that contains this double bond O is going to end in O8. Right? So here we have methyl propanoate. Right? And this OATE ending tells me that prop 3 carbons with a double bond O then connects to an O, which then connects to a methyl. Right? A lot more complicated with words than it will be when I start drawing them out. But again, if you can look at this and draw this substance and match up the pieces, right? Where's the methyl? Where's the one carbon by itself? Prop, where's 3 carbons in a row? Right? If you can dissect the example, you can always, always, always name the thing. So we're going to take a look at some examples of both of these things together. Right. If I have something like methyl ethyl ether, I'm going to work back to front, right? The same way that I always do. An ending with ether means that I know I have an ether, right? It's telling you right out front, which means that there's an O with some carbons connected on the left and some carbons connected on the right. I have methyl ethyl ether. Ethyl is the prefix for 2 carbons, and YL tells me it's a branch. Meth is the prefix for 1 carbon, and the suffix YL tells me it's a branch. So I have a 1 carbon branch and a 2 carbon branch connected to this O, connected it because it's an ether. So when I've finished drawing it out, I want to put 1 carbon over here and 2 carbons over here. Right? Methyl ethyl ether looks like this. Here's your methyl, here's your ethyl, and the ether. Now, I know the question is going to come up, does it matter if you do this? The answer is no. Both of these things are methyl ethyl ether. It doesn't make a difference if you draw them one on the left, one on the right. The order that they're listed in here doesn't matter, right? So it doesn't mean that the first thing is on the left or the second thing is on the right. You can draw it as long as you put those pieces together. It does not matter which way you draw the picture. For the next one, we have diethyl ether. Right, which again, ether tells me that there's going to be an O connected to two branches. I recognize ethyl, right? That's a 2-carbon branch. But diethyl is new. And when they say diethyl or trimethyl, right, when they use these prefixes before the prefixes, it's telling you an amount. So diethyl ether, right? Di is the prefix for two things. So it's the same as saying ethyl ether. Right? It's ethyl twice. So when I want to draw this thing out, it's a 2-carbon branch and another 2-carbon branch to go on either side of the O, which is going to give me a molecule that looks like this. And this would be diethyl ether, or if they say ethyl ether, there's no difference between the two here. Finally, looking at our last example here, we have methyl propyl ether. Again, prefixes tell us how many carbons are going to go on either side of this O, right? Ether tells me O connected to 2 carbon branches. Propyl tells me 3 carbons, so I'm going to put 3 carbons single bonded together. Methyl is the prefix for 1 carbon, so I'm going to put 1 carbon bonded on the other side. Again, I'm gonna stress this, and I can't stress this enough. It's not that it's a really difficult thing. It's just a different pattern, which is why we're taking the time to go over it separately from the others. And the same thing for our esters, right? They're not super difficult once you've seen a couple. Right, so when we move on to our esters and we take a look at these, for an ester, right, remember the functional group is going to be C with a double bond O and an O, and this is going to connect to something, and this is going to connect to something. So by having an ester, it's just like an ether, right? An ether was just this connected to two things. So we have these paired together because they're similar, but here there's the C double bond O in addition to just the O breaking up the straight chain. And so when these things get named, we need to account for where the double bond O is, because this molecule is different than this molecule. Right, so because there's a difference, we can't do what we did with ethers, where we just said this is the same as this. Right, because they're not the same anymore. This double bond O means that we can't just do what we want. When we have an ester, we have still the naming convention. Here's a branch, but here we have hexanoate. We have this ending of OATE, and the OATE is going to tell you where this goes. We're still drawing from back to front, right? O8 lets me know that it is an ester, so I'm going to draw my ester functional group. Hexanoate, the fact that it's connected to the O8 means it's going to connect to the double bond O. So we've got 1, 2, 3, 4, 5, 6 carbons. Hexanoate. The methyl means it's going to be a branch coming off of the other side, so we're going to put our single carbon branch there. Finishing our drawing with H's on every carbon to make sure that every carbon has 4 bonds. When we look at another one, let's look at pentyl propanoate. Right? Again, we're going back to front. So O8 tells me it's an ester, so I know that I should be starting with my ester functional group here. Propanoate means that I should be starting with 3 carbons. Prop is the prefix for 3 carbons. Right, meth, eth, prop. 3 carbons in a row here. Nope, too many. And then the pentyl means that I have a branch coming off of this O, and it's going to be 5 carbons big. 1, 2. And to finish up the drawing, you put your H's around to make sure every carbon gets 4 bonds. Looking at our last example here, we have ethyl butanoate. Again, the O8 ending lets me know that I'm working with an ester, and so I need to start with my ester functional group. Butanoate, the fact that it's all connected to the O8 means that it is connected here. But is the prefix for 4 carbons, so we've got 1, 2, 3, 4. Ethyl is a branch coming off of the O, so it's going to be ethyl 2 carbons. And we're going to finish that drawing by putting our H's on each of the carbons that needs them, so that every carbon gets 4 bonds. Alright, so the question is, so it always goes before the O. What always goes before the O? The double bond. The double bond goes on this oxygen specifically. If you look at table R, which I can pull back up for us, right, it actually shows you here's the double bond connecting to the O, here's single bond to O, and a single bond to the rest of the chain. Right, that means that this carbon does not need any extra bonds. Ah, I see. Yes, it has to be connected to this. If you did, for example, I see what you're saying. If you did this, that's not an ester anymore. Right, so an ester is specifically this setup. C with a double bond O on it, directly connected to the other O. Right, here you have a ketone and an ether. Right, this is just a double bond O connected to stuff. That's a ketone. This is an O connecting two branches. That's an ether. So it's not an ester. We're not going to deal with mixing functional groups, so you're not going to have to worry about that. For an ester, yes, the branches are always going to go in this spot. Right? So this is where your branch is going to go, and this is where the rest of the chain is going to go. That's just the convention for naming esters. Right, I'm going to redo the last two of these with color coordination so that we can look at them in a little bit more detail to break down the names. But after that, that's all I got for today. And so we're going to look at some color coordination. We're going to go red here. We're going to go blue here. We're going to go purple here. All right, so the ether is the O, always. Methyl is going to be our single carbon branch, and propyl is going to be 3 carbons linked together. All right, so when you have methyl propyl ether, this should be what your drawing looks like. It does not matter, right? Again, or it does not matter if you put the 3 first and then the O. This is the same exact thing. There is no difference between these pictures that I am putting up. Right, so the ether, the word ether tells you there is an O connecting 2 branches. And then they tell you what the 2 branches are. It doesn't matter if you put the first one on the left or the first one on the right, as long as you have one on either side of the O. Right, for this one, let's keep our same pattern here. Red, light blue, and purple. Right. 08, the ending 08 tells you that it is going to be an ester, right, which tells you it is going to be that functional group. Bute is going to tell you that there's 4 carbons. So we're going to put 1, 2, 3, 4 connected to the functional group itself. And then ethyl is the prefix for 2. And so we're going to put 2 carbons there. And then with our final color, we're going to make sure every carbon gets 4 bonds. And that's the picture for an ester. Right, this carbon on the functional group is part of the bute. Up there. Right, so we're not going to add 4 additional. There are 4 total, including this one from the functional group. Right, so that carbon is both part of the O8 and part of the bute, which is why I alternated these colors here for the purple and the blue. Right, tomorrow we're going to look at our last two functional groups, our amines and our amides. But that's all I've got for you for today. I will see you all tomorrow. Oh, also the general, right, if you have questions, comments, or concerns, you got things you want to talk about, come on over to office hours and we will talk more there. Take care, everybody.